So now that we have a formula for finding the distance between 2 points, we can look at some examples, right? And that's what we're going to do in this lecture. We're going to start off with a practical application. Then we'll also look at some kind of more theoretical problems. So what I have here is a situation that we see in software development. You notice that if you've got your computer open and you move your mouse around, sometimes the mouse changes, right? When you get over a hyperlink, for example, your mouse changes from an arrow pointer to a hand, maybe to some other kind of pointer to indicate you've crossed into a special area of the screen. So that's what we're talking about here, right? When a mouse gets within 10 units of the center of an area. So we have this point here, right? The center of the object is going to be at 112.83, 112.83. And I know where the mouse pointer currently is. It's at 114.80, so it's over a little further and not as high up. So it's down here somewhere, 114.80. And I need to know, is it within that 10 unit radius? So in other words, there's this circle around this point that's 10 units. And I don't know, maybe it's here, maybe it's out here. I don't know. I need to find out if that point is inside that circle or not. So the way I'm going to do this is I'm going to find the distance. Let me clean that up a little bit. Right, I need to find this distance here between those 2 points. Unfortunately, we have a formula now, right? Remember, our formula is D equals x2 minus x1 squared plus y2 minus y1 squared, and we're going to take the square root of that whole thing. All right, well, let's put our numbers in here and see what happens. All right, so I'm going to do 114 minus 112 squared plus 80 minus 83 squared, square root. 114 minus 112, that's 2. 80 minus 83, that's 3. Square root of that whole thing. So this is 2 squared, 4 plus 9. This is the square root of 13. Now, that's not the answer, right? Because you go back and look at the question. The question said, is it close enough that the operating system needs to make a change? So what I really need to know is this distance less than 10 units? If it is, the answer is yes. If it isn't, the answer is no. And you can get your calculator out and ask what the square root of 13 is if you like. But I know that the square root of 13 is less than the square root of 16. The square root of 16 is 4. That means the square root of 13 is less than 4. And if it's less than 4, it is certainly less than 10. So the answer is yes. The operating system does need to make whatever change it's been told to make when something gets close to that area. All right, so here we have something that's a little more theoretical. I want to find all the points that are a certain distance from this point and that are on this line. All right, let's graph some of this stuff. All right, so I've got the point 3, 2 that's over 3 up 2, that's here. And I've got the line x equals 4, so I'm going to go over 4 units. X equals 4, that's a vertical line, and there you go. All right, so what I'm going to do is, and I know the distance, right? The distance is the driver here. So what I'm going to do is I'm going to pick an arbitrary point on this line. Let's pick right here. You can put it anywhere you like, right? It's just to help us visualize. So what are the coordinates of this point? Well, I know it's x coordinate. I had to go over 4 units, right? It's on this line, x equals 4. So the coordinates of this point are 4, some y value that I don't know yet. All right, that's all I need, right? I know that this distance here is 3 units. All right, let's go to our formula. D equals the difference of the y's, difference of the x's, square root. All right, so let's put what I know in here. I know that D is 3, and I know the x's. The x's are going to be 4 minus 3 squared. And the y's are y minus 2 squared. Okay, all I have to do is solve this. Right, solve this for y, and I'm home free. So let's see. Let's simplify what's inside here. 3 equals 4 minus 3 is 1, and 1 squared is 1. I'm going to get this. Now, please, at this point, resist the urge to multiply that thing out. Right? I'm looking ahead. There are no variables except that one that's inside that square thing. Everything outside of there is a number. So I'm thinking I'm going to get to where I can just take the square root of both sides and save myself, multiplying out, doing the FOIL thing. There's a more than half decent chance it's not going to factor, so I'm going to have to go to the quadratic formula. I'm going to make my life a whole lot easier if I just leave that like it is. All right, so from here, let's square both sides. 3 squared is 9. The square root goes away. 1 plus y minus 2 squared. Let's move the 1 over. 8 equals y minus 2 squared. And here you see what I'm talking about. Take the square root of both sides. The square root of 8 is the square root of 8. The square root and the square cancel, and I get y minus 2. Now, you got to be careful. This is not it. Right? I left something out. This is a very common mistake. Remember, when we're solving an equation, and you take the square root of both sides, you have to put plus or minus in front of that square root. All right, so add 2. Y equals 2 plus or minus the square root of 8, and we're really not done, right? 8 is 4 times 2, so I can simplify this a little further. Y equals 2 plus or minus 2 times the square root of 2. And that's it. Well, okay, for what was the question? The question said find all the points. That's not a point. Those are just numbers. All right, so my answer is the points I'm looking for are the points 4, 2 plus or minus 2 square roots of 2. And there are 2 of them. Right? There are 2 of them. And if you think that through, hopefully that makes sense to you. I drew my dotted line here going up, but I could just as easily have drawn it going down. Right? And you see that did end up below the x-axis, give or take my sketchy drawing skills. But if you go to your calculator, one of these numbers will be positive and one will be negative. Right? So that's kind of consistent, right, with what I'm generally seeing in my graph there. So there's my final answer. All right, so here we've got something that's a little busier, a little more complicated. Let's see, what do we know? We're given 2 vertices of an equilateral triangle. One is at 0, 1, and the other is at 0, 7. And just real quick, just because I know it, this distance is 6. So there's another point out here somewhere that kind of completes this equilateral triangle, right? And I know that this distance here is also 6, so is this one, and I already put it in the drawing, right? This distance is 6 as well. Okay, so what do we know? Well, not much, at least not yet, about this point. So I'm going to call it x, y. Now, I could go to the distance formula. I mean, this is 6 and this is 6, right? It's equilateral. But I'm going to have to do it with both points. I'm going to have to do x, y and 0, 1. And that's going to give me an equation with 2 variables. Then I'll do it again with x, y and 0, 7. Again, I'll have 2 variables. And they're going to be be squares in there. Well, we could probably do it, but look, if we pull out a little something from geometry, we can make our lives a whole lot easier. If I draw this altitude here, right from the point I'm trying to find down to the base of the triangle, that base of the triangle, that makes a right angle. And I know, like I said, I'm going to pull a little geometry out here. The altitude of an isosceles triangle, which this is because of the 6 and the 6, right? The 6 and 6 are the same. So this applies to equilateral triangles as well. It bisects the base. That means I know that this distance is 3 and this distance is 3. Right? And that means, remember I've got this 1 down here, that means this is the line y equals 4, and that helps me out a lot. I can replace that y with a 4, and now I'm down to 1 variable, which makes me much happier. So let's go to our equation, our formula. D equals the distance of the x's squared plus the difference of the y's squared. I won't necessarily always write this out explicitly first. Sometimes I'll just drop the numbers in. But especially when you're starting out, it helps to write it over and over again, right? It helps to kind of get it into your memory. All right, now let's put numbers in. First, I got to pick a point. It shouldn't matter which one we use. Obviously, I have to use x comma 4. It shouldn't matter which of the other two I use. I'm going to use 0 comma 1. You're welcome, if you're doing this along with me, you're welcome to do it with 0 comma 7. You should get the same results. All right, so let's put numbers in here. 6 equals the difference of the x's, that's x minus 0 squared, plus the difference of the y's, that's 4 minus 1 squared. So x minus 0, that's at x, so this is x squared. 4 minus 1 is 3. 3 squared is 9. Square both sides. 36 equals x squared plus 9. Subtract 9 from both sides. X squared, excuse me, x squared equals 27. 9 and 27, yeah, 36, good. Square to both sides. X equals plus or minus the square root of 27. 27, that's 9 times 3. So x is plus or minus 3 times the square root of 3. And now I can answer my question. Remember what we were asked for? We were asked for the coordinates of this point. So the coordinates are plus or minus 3 square root of 3 comma 4. And there are 2 of them, right? Because again, I drew my triangle going to the right. There's a corresponding triangle over here going to the left. One of them is 3 square roots of 3 to the right. The other is 3 square roots of 3 to the left. Yes, that makes sense. Good. So there's my answer. All right, so that's the distance formula, right? We've seen some basic things with it. Now we're ready to really start talking about start talking about conic sections proper. And to do that, we're going to jump in and start talking about the equation of a circle.